So someone mentioned a few days ago, I think something about pi entering popular culture and being very impressive, that there was so much pi in popular culture. Is the OMA on the monitors? I have my own monitor here, but all right, so I'll do that. Try to tilt it up a little bit. So I have some more evidence to add to the pi in popular culture is the commercial exploitation of an approximation to pi, which is some local fast food place is advertising that on March 14th I could buy something for $3.14. So my talk is about approximations. Last gathering, I gave a gift for the gift exchange book, and my gift was meant to be printed on 2 separate sheets of paper, but of course books are printed double-sided. So the only way you could have used my gift was if you had a friend who could tear it out and fold it in half and give theirs to you. So this year I've improved it a bit. I have a bunch with me that people can get later if they would like. I'm going to show you how to use it. So there are these 2 sheets of paper, and one of them has a whole bunch of curves. These are actually functions in one variable, simple functions in one variable. And the other one has a straight scale that's labeled, and again, I'm going to magnify this for you later. The other one has a straight scale that's labeled with a bunch of simple constants and a whole bunch of instructions. This is gathering 13. So let's suppose we were going to approximate 1.313. Now, a lot of you probably would think of 130 over 99, which is a darn good approximation for 1.313. I thought of square root of e minus 1. That's also a decent approximation to 1.313. But suppose you didn't want to go through that kind of effort, and you just want to have some kind of tool that can automatically do the job for you. So what you do is you take the edges, the registration lines, and the scales on both sides. You find the 1.313, and you kind of line it up. The instructions, the printed instructions here, kind of explain it in better detail. In the interest of time, I have one that's already lined up to 1.313, and I'm sure it's not going to be in focus, so I have magnified the area that you're working on when you line it up, which is horizontal alignment and vertical alignment indicated by 2 colored lines here. And you do the same thing kind of on the other side. You do the same thing here and here. And then you just have to scan along the edge of the paper to find a function whose value is equal to a constant. A function in one variable whose value is equal to a constant is like an equation with a left-hand side and a right-hand side. So again, I just showing 1.313 as close as you can get, and you kind of look and see that pi x is approximately equal to e to the power of the square root of 2. There are other solutions you would find in here, including the one I mentioned earlier, and let's see, the 4th root of 3, I guess, seems to be a decent one. So this is the way I think we would have found approximations back in the day that I started reading Barton Gardner's column. It's purely analog, which is why I call it the analog approximation finder. And let's see, was there anything else I was going to say for this? There are also other types of problems that you could solve with this tool. You could actually say, try to find an approximation for pi that doesn't involve pi, or sines or cosines. And spoiler alert, square root of 10, good answer. I have a program that does this too. Of course, I did use a computer to prepare the gift. I was mentioned in a comic called XKCD, where they made a lot of these silly approximations, and he did use Mathematica a lot, and he doodled around on his own and found some on his own. But anyway, if you want to find the PDF and print out your own, all you need to do is Google the author and title of this talk, and you will find the PDF of the gift I made for 2 years ago. You can also go to this mrob.com/reese/nomo, which is, yeah, I don't have it on this written on one card to show you at the same time. You can also go to mrob.com/Reese to get the program, the full program. And in the interest of our numerology today, we have the 13 symmetries, the rotational symmetries of the cube, matched up with my name, the 13 cards of a suit matched up with approximation, and the 13 constellations of the zodiac matched up with the website, mrob.com/Reese. So that's all I had to say about that. Hope I'm ahead of my time. Just barely. Yeah, thank you.